The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. It was huge. They were watching out for each other.
Hello, everybody. Thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dan started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Hello, everyone. Welcome to our Hawaiian Volcano Tracker for February 26, 2026. We are HVERI, the nonprofit Hawaiian Volcano Education and Resilience Institute. I'm geologist Philip Ong, joined by Mr. Dane DuPont. We got Lou Tori backstage helping us produce, and our interpreters, Dano and Gary Kaufman, as usual here today. So today we'll give you guys an update on what's happening on Kilauea. Hasn't been a whole lot in the last few days. Dane, how's your week been?
Yeah, I've been, dealing with some of the other elements, so to speak. We've been dealing with a lot of height surf out here and some winter weather, a lot of rain. So that's been more on the radar, so to speak, currently. But, looking forward towards the next episode. Might be a little bit away, though.
Yeah, we'll see. We'll dive into it and dig into all that here and do a little bit extra on deep earthquakes have been happening under and around Kilauea Summit this past week plus.
Yep.
All right. So, yeah, as usual, Dana will be leading discussion in the chat along with Lou, collecting questions for us to discuss as we go along. Anything else, Dane, before we get into it here?
No, I think that's it. Let's do it.
All right. Let's get ourselves set up for our summary. And one more thing here. All right. Hello, everyone. This is our Hawaiian Volcano Summary for February 26, 2026. It's been 11 days since episode 42 of Kilauea's ongoing summit eruption, and the volcano continues to recharge and refill with magma, albeit a little more slowly than we've seen in past cycles. This is a live view at the V3 camera, showing both vents with volcanic emissions coming from there and blowing off in the trade wind direction at present. And I'll show you guys a time lapse of the nighttime views from that same camera over the past week. You can see there's been glow from both a south vent and a north vent over this past week, with the south vent being a little stronger and more persistent, although both of them are intermittent, as you can see here. We've also seen in the last night, especially, some flaming from the north vent, as you can see illustrated here. There are several instances of this. This is just one of the better ones to share with you guys. And all this is happening as the volcano continues to recover its loss of ground tilt that we saw during episode 42. So there is that drop in the ground tilt, and the recovery has come up in a traditional trend, although it's been interrupted by 4 of these mild deflation cycles. There's a first, second, the third, and we're currently, as we speak now, in the 4th. And so that's slowed things down a little bit more, and it's a little unusual. We haven't seen these cycles come quite as early in the recovery phase, although they have been common in the later phases of this buildup. So we wait to see what that means. That could mean some changes in the onset of fountaining or in the nature of the eruption at some point, although it's too early to say anything more about that. The current USGS forecast, based on the preliminary data, suggests the forecast window is between March 6th and 16th, with a caveat that given more deflationary cycles and more data coming in, this is subject to change in the days and a week ahead. So that's the current window, and just to remind you, everything has been erupting within the summit crater of Kīlauea in Hawaii Volcanoes National Park, and occasionally putting gas and ash out of the crater. That's what's been the biggest impact to people here. So with that, we'll focus on the daytime views from the B1 camera here, showing the wind pattern over the last week. Trade winds blow the fog plume to the southwest, and you can see there have been plenty of days over the past week where the direction has been more to the east, at least a couple of days there in the last week. And we can catch a couple of satellite acquisitions as well, which you can see here with Kilauea source in this red triangle with the fog cloud over on East Hawaii. This was on Sunday, and this on Monday, where we see perhaps a higher plume with a higher concentration drifting to the east of the volcano there. So as it currently stands, the National Weather Service says that trade winds continue today, but will ease this weekend as a front approaches from the northwest. That could mean more foggy conditions this weekend. However, they say that a more typical trade wind pattern looks to return by the middle of next week, which is just ahead of the onset, the opening of the forecast window from the USGS. Even still, in this inter-episode time, there is fog blowing out, and these swirling winds have meant a lot of fog across much of the island, as you can see in the VMAP forecast dashboard here, not just on Hawaiʻi Island, but at times over on Maui as well. This is the particulate aerosol layer of fog here, which you see lasts longer in our atmosphere. If we look at current conditions from the Purple Air Citizen Science Monitoring Network, you can see that there are some elevated readings across several parts of the island, especially in West Hawaii as we currently speak. Elsewhere, we have earthquakes on a volcano still occurring. These are plotted by depth. So the blue ones are deeper, the reds are the shallowest, and orange and yellow are in between there. So we're seeing a typical pattern with the blues down here in the Pahala hotspot source area. But there are a few additional blue dots over here, and especially in this area east of the crater right up in here. These complement the ongoing normal pattern of south flank events and summit events that are shallower as well. So if we look at a cross-section of this map for the past week, you can see that these are deep down under the volcano, part of its root. Here's Pahala off to the west, and this is the new population of earthquakes for the last week. And here for the last month, you can see it's happening a little bit more. And these are occurring in this area more or less in here, which is a predetermined, researched pathway of magma from the volcano as it comes from source. There's lots of different information in here, and you can watch our full update if you want more information on these magma pathways here. But a lot to say that this is not unusual behavior, and there's nothing to worry about. This often happens when you have a recharge of magma into the roots of the volcano. Elsewhere, we have earthquakes also on Mauna Loa. We have a 3.1 and a 2.8 northwest of the summit. These are also part of the normal recovery process of Mauna Loa as it continues to refill with magma following its 2022 eruption. The earthquakes per week are still fairly reasonable here. You can see they've climbed a little bit higher than they were earlier in the year. But in a long-term earthquakes per month, you can see that we're still quite a bit lower than anything we saw prior to the 2022 eruption, which is this left part of the graph shown here. So everything is essentially normal, but those earthquakes may cause some interest. And so here we can show that the crater continues to expand north and south across its summit caldera and rise upwards at the same time as it refills with magma. And Mauna Loa remains at alert level normal and aviation code green. So that's our Hawaiian volcano summary for the week. All right, let's go to our hazard summary next and look at the gases, which are the main concern for us most of the time in recent months and years here. So to start off, I'll show you this view from the KP camera on the side of Mauna Loa looking south. The Kilauea summit's down here. There's that volcanic plume blowing left to right. That's the trade wind direction. That's what we like to see. And as you'll see, there'll be some weather coming through here. Obscures a lot of the view from this distance, but you do see that there are some frames. I'm going to pause it and pull it back here. There are some frames in here where you do see this cloud rising and blowing off to the west. And this is, of course, what we've now learned to be concerned with, because if this occurs during the fountaining, this is a scenario that puts tephra over in communities to the east, as we saw in episode 41. So those conditions are still coming from time to time, and it's just a matter of whether they coincide with the actual fountaining or not, whether we'll have impact on our communities or not. So here's a view of those variable winds from a little further away. Let's come in closer to the KW camera. With our events on the right, you can see a lot of the fuming spots on the crater floor, also tracking the direction of the wind. And you can see it's blowing towards the overlook and viewpoints on the camera here from time to time, showing how it's still variable. We're still in February. It's still winter here. Our next front is coming down, and that's all part of the ecosystem we're dealing with now. So that's a view from the north here, from the KW camera. You've seen the view from the south from the B1 camera. I'm going to show it to you again because I think this is a great view. We're actually missing a day on the 22nd. Most of these cameras from USGS seem to cut out and not update. So that one day where we have that tallest satellite capture, we don't actually have captured on imagery here, but you do still get the trend of what's happening overall. So continuing our tour of summit cameras, recording VOG, here is the K2 camera at Wikahuna Overlook. You can see there are times where this cloud is going very vertically straight up rather than blowing down along the ground during normal trade wind directions. So that is the K2. Let's move to the V1 next, which is a little bit tighter view, but one you guys may be more used to seeing if you are a live stream follower of the USGS. And you can see that there are many times where the camera is completely white, obscured by the VOG plume. And the same is true of the V2 camera, which there it is. It's shooting further across the crater from the volcano house perspective. You can still see the volcanic plume dancing around there, left and right and straight up, and straight at the camera sometimes too. And finally, here's a V3 camera where we started showing that swirling wind and VOG once again. So that's what we still watch out for. It's still been happening, and we'll keep our eye on that in the week ahead, especially. Looking at the VOG measurement and prediction program out of UH Manoa and their VOG forecast dashboard from the VMAP. We'll start off with the SO2 pollutant layer here, which is the more pure concentration of gas emitted from the volcano. You can see it's a little bit closer to the source here in this forecast, but it does drift significantly southwest, as is typical, all the way past Ocean View to South Kona, and also north into the Saddle region and up Mauka of Hilo as well, and all the way to almost the coastline of Hamakua. But as we've discussed before, this reacts with the sunlight and water and creates these sulfate aerosol particles, which are this other layer here. And that stuff can linger for longer. And so here, when we switch to that layer, you see a much brighter yellow and orange map here. And part of this is as this storm front approaches from the northwest, it's going to pull air towards it or push air push air away in other directions. And in that way, we get the swirling wind pattern that the VOG can really go all over the island here and well offshore and even up into Maui at times too. Looks like even a little bit of Molokai. So that's the forecast. We can look at some of the interactive maps right now. This is the state air quality data map. It's showing green for most stations, except for the Ocean View one, which is here in a yellow. And you can see skirts that line quite a bit of the time. Some of the other areas don't have yellow, but they're still in the high green range as well. So that's Waikoloa Village right there. And this is actually catching all the different particulates. So there's a chance that some of these values in Honolulu or in Maui might be from other kinds of air pollution, whether it be dust or, ash from fire or vehicles or that kind of thing. So this is capturing all of that together. But when we come here close to the volcano, we know that it's very rural and not a whole lot of people and not that many cars. So it's these numbers that we see are quite likely volcanically derived. And coming to our purple air once again, showing us the same pattern, a little bit more data density, more dots on a map all around. And you can see that they're also a little bit more sensitive. They turn their greens a little bit more yellow, and you can see this whole range of it all through here. Highest station at present looks to be down here in the South Kona, where you can see. Let's give this a little extra attention. And that one's not loading for us, but looks like it's for the last 6 hours or so been skirting the edge of that. Oh, here we come. Skirting the edge of that yellow zone right there. Actually comes in and out of it. Let's see if I can get that. There we go. Graph to actually show without being obscured. So that's still our main concern is the VOG at present. And finally, in a national park, the summary is showing green at all the summit locations and the locations away from Kilauea summit as well. At present, the wind has picked up a little bit, but it's not very fast still, 6 miles an hour, 3 meters per second. And over the last 48 hours, all the red bars have scrolled off of here, but there was some, I want to say that the last one I saw might have been over here at Uekahuna, where there was a little bit of a of a peak earlier yesterday. So at present, looking pretty good. It's looking pretty good through tomorrow. And perhaps this weekend we'll have the changing weather, as we'll see from the forecast here in a minute. But looking at the MOUNTS project, which is a satellite capture of these SO2 emissions, we'll go back to a week ago on Friday. And sometimes it doesn't catch hardly anything because it's dispersed, or maybe it's obscured, or it's up in the upper atmosphere being more dispersed. In the case, we're not seeing much on the 19th. The 20th, we're seeing a strong trade wind pattern with everything blowing southwest. 21st, it's in the upper atmosphere a little bit more dispersed. The 23rd, it's really the 22nd because this is Greenwich time right here. So it's back on the 22nd, we're seeing that eastward push of VOG, a little higher concentrations here in the Puna region. And on the 23rd is this one image that captures all this red here. And this is what corresponds to the USGS report of very little wind and a plume rising very vertically into the sky. And perhaps that's what we're catching here. A little hard to track this. As we mentioned, this is a day the cameras from USGS all seem to have gone offline and don't really capture that view that corresponds to this capture here. So this is what we're concerned with if it happens during a fountaining episode right here. So out of the last week, it's really been those 2 days out of 7, right? So that's about more or less our rough odds right now. Coming to the next couple of days, you see it's a little bit more trade wind, but dispersed. You still see some stuff south and southeast of the summit. And the last image today, you can see here, well, not today, from yesterday, is mostly to the southwest, but with some spilling to the north as well. So those are the current captures. I can show you guys USGS updates from Sunday, where this is what one of the things they're showing and noting now is on the webcams whether there are trade winds or slack winds or southwest winds. So Sunday we had slack winds, and on Monday they noted little to no wind with the plume rising vertically. We mentioned before the National Weather Service area forecast and its discussion, noting that moderate trades continue today, will ease tomorrow and Saturday as a front approaches from the west. It should be fairly dry the next few days, they say, until Monday and Sunday and Monday. And then finally, by midweek next week is when we see the return to more typical and breezy trade wind pattern, as you see right there. So the easiest way to show you guys this without reading more is just to bring up this animation from the Mauna Loa Weather Center, showing the GOES 18 satellite layer here. And so there we are, right there, Hawaiian Island, and here is this big front that is approaching from the northwest, as it does in the winter. So that's what we'll keep an eye on into next week. All right, and it's interesting because you can see that within this front and overall this flow, there's a lot of this movement to the northeast. And if we look at the windy.com SO2 layer, we can see that all the VOG that's floating around our island is actually also an upper atmosphere getting pulled and sucked off to the northeast. And if I zoom this out, you'll see that it's shooting presently up towards Oregon, more or less in there. But also, if I keep zooming out, you'll see that at present there actually seems to be quite a lot of sulfur on its layer and across the entire globe right now. So might just be a little drop in a bigger pool here at present, but there is our source and where it's going right now. So that's about all I can say for the VOG at present until we see some more time pass. So we'll move on to our visual observations here. And I will start just by checking in on our live cameras. Here is the V1, the V2, not showing much, and the V3. We'll start off showing you guys looking pretty good here. For the last week, this is the thermal camera, and I'll play this animation. And really, there's not any change. You can see some changes in the glow and the fume of the vent over here and moon rising. But that's really it. No other changes visible on the crater floor. Otherwise, if we look at the overnight glow from the V1 camera, you see there's a little spot way off here on the rubble pile. But in the foreground is the north vent, and the background is the south vent. And you can see that intermittent glowing pattern across the week here. And the V2 is farther away, but showing you what you might see from the ground at Volcano House. You see that south vent, north vent, and that third spot of light that's on a hill up here behind the north vent that was persistent earlier in the week, but has not been seen since. And finally, the V3 camera for the last week. There's that little spot early on, and north vent, south vent. And I'm basically taking an image every 15 minutes or so here and speeding through it. So we don't catch a lot of the finer details. We just see the overall big picture. And so to get a little bit more refinement, let's bring in Lou and have him add some observations from his perspective. How you doing, Lou?
Hey, I'm doing good. Keeping up with you here tonight. All kinds of stuff. It's kind of interesting, you know. We first of all, welcome back to our interpreters. Dano, it's good to have you up above me there. I will take it easy on the observations with you and save it for community corner. You know, with the visibility being off and on, especially on the V2 cam, even inside the vents with the degassing, there has been some things happening up there. Let's go through those right now. Philip showed you the flames earlier. Here's some nighttime flames that were going on. And I have some music that Dane created for us in the background there. Thank you, Dane, for hooking us up with that. This is off the V1 camera and the north vent. Here's that morning shot right there at 6 o'clock in the morning. I have an image coming up here. If you're curious if you can see anything during this time, you can. So if you are up there, whether it's over on the Keanakekoi side, Waikahuna, there's a shot right there from Janice. Thank you for hooking us up with that. You can see what's going on. Here's a collapse inside the south vent. I've got to say thank you to the Pineapple Mods. They have hooked us up with some good stuff. They are always on it for me. I sped it up a little bit and zoomed in a little bit so you can see the collapse inside the south vent there. But I have a better one coming. Is that pretty cool? Look at this one.
Yeah, it's subtle back there, yeah. But yeah. I saw that gray stuff falling in, and I see a little dust plume coming up now.
Right. So one thing that I'm curious about on this collapse right here. So I'm going to back it up just a little bit for us, because the time that it came off the wall, let's get it here, it'll pop back on. The time that it actually started crumbling and dropping into that vent, Philip, we've talked a few times about how deep that actually is. And you can see how long it takes before we actually get that dust cloud to come up out of there. It's pretty deep.
Yeah, it sure is. And it's hard to get any perspective on this as usual, right? Like there's no person or tree standing there.
Right.
That's a big hole with a lot of stuff falling into it, yeah?
Yeah. I'm going to speed it up here, make it a little bit more entertaining there. But that's actual real speed. Here we go. They're just sped up about 5 times. And here's a little flyby that happened today. Today was a big day because the V3 cam was replaced again. First time was when it got smothered in tephra and lava. This time was because of technical issues, maybe data interference. They're working it out, but the new camera is up, and we're all kind of curious on what we're going to see tonight, if we have a little better visibility, if the camera's a little bit of an upgrade. So I would check the live cams tonight. And there's a shot of a flyby. We know the birds are constantly flying up there. one of the members grab that shot for us. So there are our observations for the week.
All right. Thanks, Lou.
You're welcome.
Should we get into the community corner here?
Oh, we can do that. Dano, you ready for me? Here we go. All right, let's
do it. What do you got for us, Lou?
Oh, tonight this is like a bonus night for me. Not only do we have a couple extra things in here, but we have Dano. So here we go. Let's open up my other screen here. All right, community corner for the week of February 26, 2026. We know that there's always some type of road activity going on up top. Pay attention. Power poles are going on. There's some trails that are closed off to walking only. So you got to be kind of aware with that one right there. Here is a shot of the new V3 cam that was installed today. It is out of bounds, so do not try to go over to it and get your 5 second of fame. And there's one of the HVO crew putting it together. There's not a final picture, but I'm imagining that it's going to be stacked with rocks on that tripod.
Probably.
There's a shot. Oh, yeah. You have to, right?
Yeah. How else are you dealing with that wind?
Yeah. Here's a shot that I took across Kīlauea looking at the vents. And there's a shot when it's actually erupting. There's an inbounds location. You can shoot, watch, whatever you want to do from your vehicle. It's a great spot if you can get a parking space. There are our viewing areas all over the park. If they are open, there are chances that they are either overfilled with parking, or the tephra is blowing in that direction, or the VOG's blowing in that direction. It's most of the time it's been at night, and you have to keep your eyes open for the park personnel to direct you, or just turn around and try again. So there are closed areas. Be aware, they're usually marked fairly well. There we go. The Kilauea Welcome Center is open because the visitor center is still being upgraded with the new outdoor area, as well as the new bathrooms over there. Parking is limited. And there is a shot of inside the Welcome Center. They've got all kinds of cool stuff, hats and cups, and most importantly, rangers that will give you information on the Junior Ranger books, visitor services, and anything else you may need to know about the park. KMC is also a great spot if you need something to drink or eat. There is food up there. Parking is a nightmare. Go slow. This is when we were up there. The shot with the red shot on the left is when we were just up there for the episode 42. Parking was a disaster. It's just so many people. If you are planning to go to the park and it is close to fountaining, you better go, because once it starts fountaining, everybody is going. This is the last time. Dane, did you hear all the news about there were no hotels or rental cars?
No.
Yeah,
but I believe it.
Yeah. Local news put that out. No, the problem with rental cars and hotels. Now, some of the rental car problem might have been that the previous episode, how many were damaged from all the tephra?
Yeah, and 41.
Yeah,
we saw that one with the broken window.
Yeah,
and how many paint damage and some other kind of damage. Air filters ruined.
Mm-hmm. So they might have taken a lot out of service. Hey, if you're in the market for a used car, stay hydrated up at the park. Some tips. Number one is safety is your responsibility. That comes from the National Park Service themselves. Dress in layers. Bring a rain jacket, even if it's not raining. Don't rely on the $1 poncho. You are going to be walking around. It will tear. We see them in the park constantly and have to pick them up because for some reason, people find it acceptable when they rip to throw them on the ground, or the trash can's overfilled. Just bring a good quality raincoat, even if it's not raining, because it probably will start soon. Wear some good sunblock if you're up during the day, and a hat doesn't hurt either. And bring water, because there's not water bottle filling stations located around the park right now. They're working on it. They'll be there soon. And here we go. Stay hydrated. Visitors to Hawaii Volcanoes National Park should bring their own drinking water. That's right. A little AI fun for us right there. It's an actual image taken out there. She is just an AI volunteer for the night.
There's no dogs though.
Hold on, everybody. I want to thank the half a dozen messages I received on Friday morning. How everybody's looking forward to some dogs, but this week we may have something a little different.
Oh God.
Yes. We have the alpacas, because alpacas played a big part, and llamas in national parks around the country. We unfortunately can't have them in our park except for tonight, where this is an AI image. So there we go. Yes, there we go. A little something fun for us. So the AI definitely screwed up. We'll go back to the dogs.
I said those are funny looking dogs.
For some reason, I was still in my same folder that I've been creating in, and my dog is a Catahoula and has the same markings as that one alpaca. So I don't know if it blended in a Catahoula alpaca. I don't know, but AI does some crazy things. All right, Kohala Resilience Hub event that's going on. So Hana Fun Day is a community celebration featuring a civil defense emergency preparedness mini fair. If you guys remember, HVERI ourselves here, we co-hosted one over in Ocean View. This is another one of those. We will be up there, and you can join us for resources and activities focused on resilience, health and wellness, and food sustainability. There's KK activities, community partners. There's all kinds of stuff going on up there. March 14th from 10 to 1. It's 3 hours up in Hawaii. If you haven't been up there, come and see us. We had a good time last year, and we're going back again.
Yep. Should be a good event. I've been working with civil defense again on this one, so see how it shapes up, but it's always a good time.
Absolutely. All right, what's going on down at the Kahuku unit is a moderately difficult 2.6 mile guided loop hike down the Palm Trail. If you haven't been to the Kahuku unit, I recommend you get down there. It was closed for a while for some renovation. It's a great place. It's got the native forest and the volcanic features down there. The 1868 Flo was down there from the Eruptive Fissures. Phil and I actually did a hike out there together one time. We've all three been down there filming different events that have happened. It's on the way to Ocean View. Please check out Kahuku Unit. It is sometimes an overlooked area of the park within on the island here. Time is 9:30 in the morning on February 28th. That's 3 hours down there at the Kahuku Unit. And a new boot brush station is available. These are not new. This actual station is new, but we have them all over the park. It's to help protect our native forests by the spread of invasive seeds and fungal diseases like rapid ohia death. Pretty simple. Spray and scrub, and then you're good to go. So every step counts. Help protect Hawaii's native forests for future generations. And you can join our email list at hveri.org. Subscribe and get notified for episode 43. That'll probably be around March 6th-ish or so. Or join just for our newsletter. So hveri.org/subscribe. I cannot speak those last few words out of my mouth. There we go, Dane. You better take over.
All right. Well, yeah, we'd like to thank everybody that tuned in today. But first, want to thank the Bye Grant program through the County of Hawaii and the Kilauea recovery grants that help keep this content, as well as support for our other programs or digital resilience and youth development going. But really, we'd like to thank everybody that's shared, subscribed, and felt so inclined as to donate. If you would like to support us, we do have a YouTube fundraiser going. Let me make sure that's on.
It is on. Yep.
Okay. And as well as we take donations over on our website, hveri.org/donate. And we appreciate everybody that's donated there.
Got
we
some
did
donations.
have one donation from Mark come through, a $50 donation. Appreciate the long-term support there, Mark. All right.
Hold on. You got Ed up there, and you got one more I'm typing in right now.
I am missing these.
Mahalo Norm from Hawaii for your $20 donation to HVERI. I just dropped that in there. And did you see Ed's?
No, I did not.
Mahalo Skagit Ed for your $50 donation to HVERI. We appreciate it.
That one's just not on my thing. Like, it just does not appear. All right. Well, thank you, Lou. And let's go ahead and bring Phil back in and get into our back half. What do you think?
Absolutely. Right on.
All right. Thank you.
All right.
And we're back. Oh, almost back. Now we're back.
All right. So yeah, we'll jump into our monitoring segment here. And I'm just going to show you one update. That's today's daily update here, where we still have much of the same information reviewed here. The most important thing is the current window is March 6th to 16th. They note here that intermittent glow from both vents, stronger and more frequent from the south. They do still note the occasional flames from the north vent and robust degassing plumes. They have seismic tremor continuing throughout this whole pause with more energetic bursts every 5 to 10 minutes. And while those bursts happening, they have increases in gas emissions and glow from the vents when it's at night. So that's an interesting pattern there, showing the magma is still in the conduit and accessible to the surface here whenever the fountains are ready to come. SO2 emissions at the regular rate here, typical of pauses. And we've recovered thus far 17, almost 18 microradians of tilt. And to remind you, in episode 42, we lost about 34. So we're a little bit more than halfway back, speaking on ground tilt. Of course, that's not the end all be all. There are other factors that could come sooner or later than that. One way to estimate that, right? But if it's been 11 days thus far, and we've come up about halfway, you might think another 10 or 11 days, that would put it, I think, March 8th or 9th, something like that. That really depends on these deflationary cycles that are happening in between there to slow things down. They note here in their analysis section that periods of weak deflation or no inflation have not been common in the early stages of these inter-fountain episodes. So that makes the tilt less predictable and creates uncertainty in the onset of episode 41. So all that said, they need more data to make sure that they're able to refine this. It's still a pretty big window, and probably because if you have more of these cycles, it could come towards the back end of this window. So that's really the summary of information put out in text. Our most recent map is still from January, but it shows stats through that point in time and our area of impact here of lava flows. And of course, we do have a satellite flying above to show us other things. And in this case, the satellite caught this more visible image. It's been colored, but it shows you the locations of the vent within a crater here, of how that looks from space at night. So pretty interesting to see that. Continuing on satellites, we have the Mounts project here, which shows us that Sentinel-2 infrared, also the gas plumes we showed you guys, but it also shows us Sentinel-1 INSAR, our satellite distance changes to the ground. And so what we have this past week, the capture was taken on the 22nd for the previous 6 days. So back to the 16th. And what you see here is this bullseye ring pattern right here towards the center, where if we go from out to in, we go orange, pink, blue, green. And so we look at the scale, and that's towards the radar direction. So this is the ground rising in this area, centered right around in here. The very middle is obscured with this speckled pattern, which is what you see when a surface is changing a little bit more chaotically, right? So it could be the actual lava flow settling or cooling, and the upper surface flaking or in that kind of movement, or it could be the actual cinders moving around on the ground, redistributing, as might be the case on the rim further up here. So that's what we're seeing in my satellite. And this is a contrast with what we saw the previous capture, which I'll show you here, which was showing the deflation during episode 42. So you see a lot more rings because the deflation happens a lot faster than the inflation. The deflation is happening across half a day, whereas the inflation is happening across 2 or 3 weeks. So we're just catching one little piece of it in this previous image that we showed you guys here. But you can see that the center, the middle of it, is the same. That area of recharge and emptying is that shallowest magma source, likely right in the middle, right up in here, underneath the central part of the crater. Other data sources we can look at, the ground tilt for the last week. You can see the last 3 of these little deflation cycles. See, they're not dropping very much. It's maybe half a microradian each time, or at most 1 microradian. Then it seems to recover, and it accelerates a little faster. So it's really oscillating here, and you can see a couple of them where it didn't really deflate at all. It just slowed and started up. And that's the pattern that is a little bit more unique. On a rift zone, it's a line in green here. Overall, we're seeing deflation. There is some signal of something happening in here. This seems like it's fairly quick. I'm not sure if this is actually a weather event, or sometimes the ground is actually settling there. It's a big cone. It's all cracked up. It collapsed in 2018. We know it still settles and moves. And so maybe if I had to just blindly guess, I would say it's some kind of ground movement around there. But it doesn't really matter, because a long-term pattern is that of after that happened, it continues to deflate, showing that it's not likely anything magmatic happening there. Plus, there's no earthquakes in the area to accompany that signal there. So a little bit of a curiosity, but not of huge concern for us at present. I'm looking at the earthquakes depth versus time here, the same week-long period. I put this together so we could try to match whether we're seeing what we saw in the past, which is when we see little deflation cycles, are there clusters of earthquakes that occur at the same time? And maybe there's some clusters of earthquakes, and there's some kind of gaps in earthquakes that happen afterwards. And this is not quite clear if these little deflation cycles are like before, where you're seeing magma looking for other spots in the cracks under the summit to go and push into and relieve pressure for short periods of time by doing that. It could be that. It could also be, if we didn't see any earthquakes at all, we might say maybe it's the actual source that's not coming up in quite as big of a push at once. It's coming up in smaller pushes, perhaps. But all that is just a speculation based on the little we see here on the signal, right? But giving us some ideas of what might be happening within a volcano. So there are some earthquake clusters here. These are not big and timed exactly where I'm very convinced by them, and the rates aren't that great overall. So I'm not sure we're seeing exactly what we saw before, but maybe a little bit, and maybe it doesn't have to quake and crack quite as much, because those pathways were previously opened before feeding the fountain, and maybe it's recharging a different shape area than it was before because of that new geometry. That's one possibility as well there. So that's the most interesting thing we have on a tilt meter here the last week. If we look at earthquake counts, they've been pretty steady across a week, with one day of a few extra here. And if we look at the map of those, as we saw earlier, the map is showing us earthquakes colored by depth. So the blues are the deep ones. As I mentioned, this is a deep Pahala source here, which we'll talk more about in a few minutes. with a little bit of this bridge right here, and then this other population of deep earthquakes right around the summit as well. So those are interesting. We'll talk about these more in a little bit, but let's focus on what's normal, which are these other shallower earthquakes under the summit. It's actually a little bit of a southwest rift trend right in here, but not too strong. So interesting, maybe there's just movement along that weakness as well. And mostly it's the south flank we see over here, right, with all these earthquakes showing continuing adjustment of this piece of land to the changing pressure up at the summit region right up in here. The rift zone itself is very free of hardly any earthquakes at all. You see some other events off axis here that are likely settling events, adjustment events on the other parts of the volcano. So that's the last week. And here's a cross section. And there are some extra deep ones down here in this 40-kilometer plus range, although most of these are in about the 25 to 35-kilometer range for the most part in there. This has been happening a little bit more. If I look at the last month, you can see a few more of these blue dots all around here, right? This whole area of them, and a little bit more populated Pahala zone with this arm that reaches off towards Kilauea summit as well. And you do see some other ones off to the south here and offshore here too. And the cross section does fill in as well, that area further on. And notice how this is a different cluster of dots than the Pahala cluster, which is a little bit further off to the west there, right? So these ones over here, right, being the Pahala zone, and then this being the summit zone that I highlighted earlier just there. So for the last month, there is our recovery from episode 41. And here we see some of those little deflation cycles and the big drop for 42, the recovery, and 1, 2, 3, 4 little wiggles in it right there. So more frequent and earlier than we've seen in previous recovery phases. And we'll look at the earthquake's depth versus time on a month-long time scale. It's also not very obvious any pattern there. We just see continuing seismicity in both the shallow and deep zones here. And this is capturing all the earthquakes on a map. So maybe if we were to split them out into different populations, we might see a little bit more, but I didn't want to go into that level of detail here with you guys today. Earthquake counts per day for the last month. You can see there was a day where they're a little higher here on the 24th, but have come down since. And so this variability is natural. And maybe this is the strongest sign of this seismicity occurring during these deflationary periods as well. So let's move, let's continue looking at some of the tilt for the last 3 months. So this was 42, this is 41, and it was before 41 when we were having lots of these little deflationary wiggles that the USGS started talking more about, these extra cracks around the summit. And so that's what we're seeing then. And you can see it's a little bit bigger scale and more extended and earlier as we speak today. The big picture for more than a year now looks like this. So here we are, and you can kind of compare this little wiggle recovery. It's pretty pixelated right in there, but there's nothing quite this wiggly for any of these other recoveries early on. If I scroll back through time, sometimes a little bit, one, but not quite so many and not quite so early. Most of them come up pretty fast right away and last that way for a while. One of the earlier ones there. So that's the tilt back to the beginning of the eruption in December 2024. And earthquake counts per week since then have been fairly consistent. And maybe back in here is when we saw that earthquake peak with the USGS talking about the possibility of, new fissures or new eruption pathways and that kind of thing. So we're definitely not in that range at all now. But as we mentioned before, maybe you did the work earlier and now you get to use it more than once. The big picture for the last 5 years, earthquakes per month, we saw lots of events prior to the onset of our fountaining here in late 2024. And since then, it's been overall relatively low. And that one peak is just that much compared to these when you look at the grand scheme of things here. What we're used to seeing with earthquake buildup before our summit eruptions here, getting quite a bit more, right? So that is a big picture there of earthquakes. And coming a little bit more detail on the earthquakes, let's just put the earthquake tag on the screen here and show you guys the map of recent earthquakes for the last week. Once again, these are plotted by depth. There's our depth scale right there. And there's quite a lot of color on this map today. So starting on the north side here, we see lots of these settling events that go from shallow to deep. We have a couple events offshore of Kona, which are somewhat shallow here, 4 and 5 kilometers deep, measuring 3.1 or 3.2, both of them right there. And another magnitude 3.6, a little bit deeper, quite a bit deeper here offshore for the south too. So all these are just different ways a volcano can settle the surface of the rock it's sitting on. The whole tectonic plate, the ocean floor, all that stuff is all moving to the northwest with the whole Pacific plate and over top of the hot spot and gaining all this heat and getting piled on and moving. And so all that stuff has to adjust, and it doesn't always adjust instantly. Sometimes it takes a while and adjusts as it goes. You know, like when you pile a stack of magazines and you walk away, and then 5 minutes later you see it actually fall over or something like that. Like it's that kind of thing, right? Where all this buildup happens over time, and then you might have the release sometime later. So that is the west side there. You can zoom into the center here. Here's Mauna Loa having one deep earthquake near the summit, but also this clustered in the northwest quadrant here, maybe more in the northern section today. But really, we've seen this area of almost always orange plotted earthquakes in this depth range, as it's kind of a block here northwest of the summit. As Mauna Loa inflates and fills with magma, it pushes and it seems to activate this area of earthquakes. And it also moves the south flank eastwards, which activates the earthquakes in this area over here. Right, so in between Mauna Loa and Kilauea, and then Kilauea expanding and pushing and then collapsing, pushing, collapsing back and forth also doesn't help this situation. That this also leads to this extra earthquakes in this in-between zone right through there. And there's our deep blue Kilauea earthquakes, Pahala ones. You can see there actually are some shallower earthquakes over on southeast flank, the southern southeast flank of Mauna Loa over here. This area on the map right through here to there, right? Including one that's a 3.1 right at the surface here that occurred earlier today. So those adjustments are all normal, but it does show Mauna Loa is filling and active there, right? She's still alive and giving us all the signals that magma is coming in, and someday she's going to demand more attention than we're giving her right now. So otherwise, there's our south flank events. You can see them going all the way down to a 1.8 here near Leilani. A couple of them, but those are just by themselves and not part of any large cluster or any swarm or anything like that. So it's probably still continuing settling and adjustment of the ground there to all the rest of the volcano doing its thing too. So that's that map. We also like to show this one, which lets us sort by magnitude. So there's our largest one is a 3.6. We mentioned these two 3.2s on Kona side up in here. The 3.2 Shalapahala, we mentioned that one as well. There is another 3.1 up here. That's the summit one we pointed out earlier, as well as a 2.8 in that area. And then we start going to the deep offshore over here, right down below 2.7. So yeah, a little bit more active this week. And given all this discussion on earthquakes, I thought I would throw in here a review of this paper that we've discussed in the past, but doesn't hurt to repeat it. And if you've not seen it before, then great, you have a chance to see it here. And this is a paper from 2005 2006 publication. In Lithos by former USGS scientists and scientists in charge, in fact, Tom Wright and Fred Klein. And these are the guys who compiled that whole 100 years of magma movements on Kilauea book that shows compiling all the data of all the eruptions over the last more than 100 years. And so they have a lot of very fine tuned analysis of all these different bits of data. And what they've done here is pull out what are the deep earthquakes and what does that tell us about the deep magma pathways into Kilauea especially. And so I'll just talk through some of the images here to tell the story. The first thing to note here is the depth in these plots is going to change. So we're starting off with a 20-kilometer depth here. What is that here? About 15 miles. 20 kilometers is 12 miles. Right there. So I'll give you some frame of reference. And in this upper part, we're talking about this really deep scale now, on this upper part of the volcano, there's a zone with relatively little seismicity right in here. That's where they presume the magma reservoir is, right? We're kind of showing everything from the side, so you do get some dots in there as well, because what I should show you is this is the map of the area, and they're projecting all these earthquakes onto this line that runs from C to B here, right there. Right? So all these earthquakes get projected onto this line, and so that's what you're seeing here. There's, from that magma storage area, a lot of earthquakes towards the surface for eruptions. That's something we are all familiar with. That's what we're usually looking at for eruptions. There's also a lot of long period earthquakes occurring below that, right? That's the feeder pathway into the magma reservoir from below. And so that's what you're seeing here. And you can see this is pretty vertical, maybe a slight bend depending on what you believe the location of the data, but very near vertical pipeline from this more or less 20-kilometer, 12-mile depth to the magma chamber and up to the surface. Okay? So that's kind of the baseline there. And so what they did is they happened to identify one earthquake in particular that occurred February 1st, 1994, right in here. What was it now? I forget what it was. I want to say it was a magnitude 5-ish earthquake. Maybe come back here into the paper and find exactly how big it was. Let's see. It was a 5.2, a depth of 35 kilometers, and a total of 132 aftershocks, with the largest being magnitude 3, took place over half within the first 9 hours following the main shock. So they talk about this, and they say that when you have that, when it dissipates that quickly, that's likely because of increased heat or pore pressure. So they mapped the earthquake right here in black, and where's the map view. And let me zoom into here. This whole area that's dotted in this almost like a speech bubble looking shape here is the area of aftershocks. All these little squares are the aftershocks. And so this one was very revealing of a potential pathway here across a subhorizontal, almost flat fault line, which was the indication of movement of the earthquake as well. That could possibly be a pathway of magma from south to north into Kilauea. And so they've drawn this. What we're looking before was this little area right in here was a previous image. This is shown as this little triangle of long period earthquakes in here. So what's below that? See, we're going down 3 times deeper than that now, all the way to here, and seeing what we see there. And so this is that zone that's going to guide the rest of this discussion. This area of aftershocks of this earthquake. Okay, so let me continue and show you guys this next version. So they've gone, and similar, here's a map view and the earthquakes plotted. Let me zoom into here, the lower section. They've highlighted all these earthquakes above magnitude 4.6 that occurred through the 70s and early 80s here, and plotted them on here as well, and noted how these, with aftershocks, right, main shock and aftershocks, right, how these are also falling in that same area, in that same zone of seismicity of the pathway. And you can go back further in time and look at the 60s, at earthquake swarms in the 60s. And same thing, you're seeing lots of earthquakes in that same area. And so here's a map view of where they are, and it's kind of hard to tell what is what exactly. So it's really useful to look at this little label right up here, right? Caldera is from there to there. So the Kauai fault zone is there to there. Here is onshore, and then that's offshore, right? So in this case, the earthquakes are occurring in the caldera to the Kauai fault zone right there. And that is exactly where we're getting ours today, in fact, right? Let me come back to the earthquake map here. And let's put on the last 4 weeks, let's say, right? So you can see it still only shows a few blue dots, not as many as the other map. But here we are. This is the caldera zone right in here. And there is the East Rift Zone and Southwest Rift. So this triangle right in here is the Kauai. And you can see that, yes, that's the area they're in. They're not really further offshore from that right there. And so I'll come back to this image. This is exactly in the depth being between about 25 and 35 kilometers. That's this zone right in here where the earthquakes are occurring right now. So they're also mapped to this exact same area described in this paper. So one more. They've noted other long period earthquakes down over here at this depth of 50 to 40 kilometers. And if you look, these are all offshore, right? So the pathway is assumed to be vertical because that's what we see other places. But it's offset from deep, deep down to shallow in this particular case right here. So during these particular events, there seems to be some pathway of magma that comes up, and then it has to move laterally and then come up again, right? And it's moving laterally through this pathway with the zone where we're seeing earthquakes right now. And sometimes it activates, sometimes it doesn't. It's very sensitive to lots of factors we don't quite understand here, but that's where it sits. And why would it go at this particular depth of 32 kilometers as it's shown in this diagram? Well, there happens to be a phase transition between spinel, which is a mineral, in a peridotite. Peridotite is think of it as an olivine-rich rock, this one with spinel. And above this line, the spinel likes to decompress, and essentially it reacts to form what we call plagioclase. Right? So it's two different kinds of rock. There's essentially two different mineral change that happens at that depth. And so it's a known boundary, and that is a place that it's believed that the magma could take advantage of that area of change and weakness and move laterally through that zone right there. So that's one interesting pathway you see, that kind of coming up and going sideways and going up again, right? But it's not the only way, let's say, because we can come to here and note that during an earthquake, well, let's see what we're looking at here. We're looking at the 69 and 1970s in this area right here. And in this case, even if you see activation of this deep zone and a pathway over this way, they're also seeing long period earthquakes straight down, straight below the caldera are very, very deep. Now we're talking about 45, 50 kilometers down, more than 40 kilometers down. And so there might be, well, there is likely more than one pathway. We're talking about one coming this way, but another one evident straight up like this as well. And during the Kīlauea days, the earthquakes that were before that event were all in this zone over here, straight underneath, if anything, slightly to the north of the caldera. And so that is also a recognized pathway of magma from deep to shallow. And finally, if we come to this map view right here, right, this is kind of going to get us into what we're used to seeing now with the Pahala zone. You look at, if you look at anything below 20 kilometers or below 20, but shallower than 35 kilometers, these little plus signs, whether they're heavier or not, that's all you see on this onshore zone, is only that depth. All the deeper stuff in here is all essentially at the coastline or offshore. But you see it's not one big cloud. It actually clusters into 3 different clouds right through here. Right? So it may be that you have actually multiple pathways using that zone of weakness coming into the volcano, right? And this is a paper back from 2006. Now, since 2006, we've had a lot happen, especially in the Pahala zone, right? Let me jump down to, let's see here. No, this one. Nope, this one right here. The Pahala swarm really picked up starting in 2015, and again, really in 2019, and to a whole other level. And earthquakes have been increasing in that deep Pahala zone right through there. And so there's more information. There's been a lot of research coming out of this. This is one cross-section that we've often shown in the past, right, where you can see the data in the upper level here. Here's our depth on the side. This is Kilauea caldera with that shallow system that we just showed you under 20 kilometers right through here, shallow magma chambers right through there. But the deep tremor on Pahala is all over here offset. And then you also see this very clear lineation of earthquakes that leads shallower and laterally through what they're terming a mantle fault zone, similar to what we're talking about here, this 32-kilometer depth, more or less, right, where you can see this pathway of magma laterally on the volcano. So maybe a similar thing coming up here, going sideways 2 feet in as well. All right, so multiple pathways there. And to show you more about Pahala, we have this cool video that was released a few years ago. This is just time lapse of the depth and distribution of earthquakes in the Pahala zone, right? So you can see that there's all these different pathways of magma that are activating and filling, and all that's moving potentially somewhat Kilauea over in this direction. Some of it going this way, and then some of it towards Mauna Loa is expected as well. So if we look at this image here, for example, they're showing similar views of Kilauea. We have the deep earthquakes here, shallow earthquakes. I didn't talk much about the rift zone earthquakes, but that's what you see in these wings over here. And there's Mauna Loa summit. And look, Mauna Loa also has deep underneath it a population of feeder earthquakes as well. So it likely has at least this one pathway upwards, but it may also have some of these, let's come up from the hot spot and go sideways and come up to Mauna Loa views as well. And depending on how you draw your pathways or your slice through the earth, that's a little bit more evident than you can see in this image right here. So one last thing that's interesting about that paper here is they note that, I'm going to talk through this here, right? So the current plate motion of the volcano is more in this direction. It's like a west-northwest direction there. And actually, if you look at the shape of the islands from Kauai down to Maui, it matches this pretty well. It's really when it comes to the Big Island that you take this hook to the south. The Big Island is kind of offset a little bit off of that trend. And so when I draw the lines of which way the volcano is aligned, let's draw, let's say, Kilauea to Mauna Kea and up, or formerly known as Loihi volcano, Kamehua Kanaloa, towards Mauna Loa, towards Mahukuna, you get this direction shown in black right here, right? So what they're showing is that the pathway of magma right now is neither of those directions. It's actually coming up like this, which means that the magma source must have been shifting to the west over time. Regardless of whether it started here or here, it has to have come west. And they interpret this to mean that Kilauea probably started off over here, actually, with a plume coming in this direction, being here when Kilauea erupts, and continuing moving off to this direction here. This is in part what explains that bend in the Hawaiian Emperor chain and this bend of Hawaii compared to Maui to Kauai off over here, right, off to the side over here. So that's really interesting, and you can see that pathway there. And if we extend that further on to Mauna Loa, then you can see that those other pathways of Pahala are even a further shift west than that, right? So that's the overall big picture of how this all works, and why is it over here compared to where you might think it to be, or offset to the south over, why is a hotspot out over here? So those are all questions for another time, but some teasers there for you to think about and why this is so cool. And so now that we've talked about the Pahala earthquakes and the feeding Kīlauea and Mauna Loa, I think what we'll do to finish off here is just go through our Mauna Loa monitoring and then the volcano watch for this week. Right? So our Mauna Loa signals are always a little bit hard to interpret here because we have all this daily variation occurring, and it's hard to see through that daily and weekly variations that are seasonal or of that nature. Earthquakes have been fairly slow. We really, on these pre-made USGS plots, are only going to get a week of time or a month of time where you see even funnier signals. And when you see something like this maybe is actually a real magmatic signal, some kind of deflation. It's hard to really tell there. It really takes more analysis from USGS and sharing that with us for us to know what's really going on. But overall, earthquake rates are still very low per day. There they are, depth versus time. You can see there's been quite a lot in the shallow zone, less so in intermediate zone, and less in deeper zone recently too. With earthquakes per week really being around 40 now, and not being that unusual. Certainly a little bit higher with this variation we're seeing now than we saw from March to, what is this here, about October 2025. And since then, we've seen more of this variation that sometimes gets higher and sometimes is about that same, or sometimes is lower as well. And here you can see that pattern a little bit more clearly from the last year, depth versus time. Look at this shallow band of reds. They're happening, but then you get a few more happening, and then a few less, and then a few more, and then they happen continuously and increase in magnitude. A little pause, and a few more bursts happening here and here. And so clearly it's evolving and its behavior over this last year and becoming a little bit more showy, we'll say, as far as the earthquakes, right? The earthquakes are more evident and happening in bigger clusters and larger sizes. And we keep seeing also some of these deep earthquakes that we've mentioned in the last few months, these possible activations of these deep pathways into the shallower regions, feeding magma into the volcano still. So overall big picture for the last 5 years, here's how it looks. We're still quite low compared to prior to 2022. And you really don't see a whole lot on that's easy to see in this depth versus time for 5 years. You can see lots of dots plotted over each other. You can see by the edges of the circles how big they more or less are. They're bigger than we see to the right. And the picture you can see here is that they have also gotten bigger in the time since and more frequent, especially right in there where you see a lot more black from these lines overlapping each other right through here. So that is the last week, last month, and the last year of earthquakes plotted on a summit. And here's our northwest quadrant sector summit, and this area southwest of the summit also is quite active, as we imagine that summit feeder dike is actually longer than the caldera itself, with a smaller magma chamber somewhere south of the main caldera there. So the USGS will issue a new monthly update next week. We're still working on a February 5th one here where everything is still normal. They noted increasing earthquakes there, but really the new information we have is going to come from Volcano Watch this week, which I'll show you right after I show you this recent picture of Mauna Loa earlier today. Still a little bit of snow there in the shadows, looks like. Not a whole lot, but cool to see that on Hawaiʻi Island. So we'll finish off with our Volcano Watch this week, which is focused on Mauna Loa. Hot off the press, Mauna Loa has lessons to teach during quiet times. And what's really most useful here, well, the text is very useful as well, but we have a new image here. So let me open this image and get it as big as possible, fitting on the screen so we can all see it together. There it is. And the top panel is 2022. The middle is 84, and the lower one is 75. And so there's a lot of things going on here. In green are the earthquake counts. So you can see the earthquake counts getting quite a bit higher before 2022 happens. Same was true before 84 and 75. The blue here is the GPS measurement. The line length change there. north and south across the caldera. And so you see that contraction and then rapid recovery, then shallowing out, but still rising over time. And that's something you also saw in 1984 and in 1975. And so that part's normal. You do see earthquakes coming back a little bit, very slowly in this previous time periods as well. Earthquakes coming back slowly also in 2022. That's what we've been focusing on recently, is these earthquakes right in here. But what they've also done here is plot in black the tilt plot. And what's useful about this is this is a tilt plot that lasts 4 years, right? So they've actually, that allows you to kind of average out and correct for all those little variations that occur and actually see the real signal of what's happening on the mountain. So that's what's the most interesting thing. They're seeing there were changes in tilt that they first noticed back here prior to 2022. We hadn't seen much change in the tilt since tilt meters were installed in Mauna Loa summit. But they saw tilt here. That was a signal that magma was shallow enough in Mauna Loa that the tilt meter could detect its movement. That was our first clue, first most obvious in the face clue that magma was right at the top of Mauna Loa there, ready to come out. And what we're seeing here is that in the most recent change in GPS, where we saw the USGS mentioned there was a shift in the inflation center from the center of the caldera to south, and south of the caldera is where that magma body that's more spherical sits. And when that happens, the line length between the caldera reverses. And so when you see this shift here, it's not the volcano losing magma, it's actually the location of its filling shifting outside of this ruler and pushing both sides of the ruler together rather than being between them, pushing them apart. That's what you see right here. And so coincident with that, recently here, from late 2025 to early 2026, the GPS is doing that, and the tilt was also doing that. And that is the first time we've seen that since 2022, and really in this history of monitoring with modern instrumentation in Mauna Loa. So what is this telling us? Magma is still close to the surface under Mauna Loa, where the tilt meter can detect it, filling and moving, but no earthquakes to speak of, really. We know the magma volcano is filling, it's being fed from deep, magma is in the middle there, but we're not worried about it erupting presently because we don't have all the signals, including all this stuff, these massive earthquake counts that you expect to have, right? So that's the story of Mauna Loa, and especially this little insight that they just offered us here today. And if you look here, let's see here. This is not the first time this pattern has been observed. In 2015, deformation seen on GPS shifted similar way, as in from central caldera to south caldera. In that case, that lasted until late 2016 before it switched back to the central body. This time it went much faster. By mid-December, it was back under the central part, right? Whereas it started off in November 2025. So they were also accompanied by changes in tilt. This was not the case in 2015. And here is where I can cite them directly. The fact that this information is detectable on tilt meters is an indication magma is still fairly shallow in the volcano, geologically speaking, possibly between 1 1/4 and 1 3/4 miles down, right in there. However, there's less seismicity at Mauna Loa than at almost any time during the 8 years of unrest before the 2022 eruption. This means that what we're seeing is likely passive refilling in the volcano that isn't stressing the crust in a way that would indicate it's moving towards an eruption. So it's filling with magma, but it's not anywhere near its breaking point because it's not showing the signs of cracking and creaking under that pressure. It's just refilling, and it's refilling openly all the way to that shallow summit magma chamber. And that's what we're seeing here. And that's why seeing earthquakes in that area and northwest, them themselves is not unusual. We're going to look for now is really any changes in the frequency of those earthquakes, and in particular, whether we have earthquake swarms start occurring, and then we'll be knowing that we're going another step closer towards the next eruption of Mauna Loa. Not yet, but that's an insight that we have here as well. In 75 and 84, it wasn't until earthquakes started again the volcano clearly began moving towards its next eruption. So that's the great insight here, and we'll leave it at that here for our Mauna Loa update. And that is it for me tonight, guys. You guys want to add anything? We got any questions we want to talk about?
Yeah, we can get some questions here. We can go ahead and do those real quick. Got this one from Mark, donated a little earlier, says, we've seen jetting from the south vent at the end of the last few episodes. We're currently seeing a more typical random inflation deflation tilt cycle. Could this mean the eruption is about to end?
It's hard. Yeah, it's hard to say that it's about to end when you see the tremor and the pistoning. That's the glow appearing, disappearing, appearing, disappearing. You know, the magma is right in there, but we know it's going to have to end at some point, right? And so that's why we're looking for these signals. And me too, Mark. I'm looking for the same things and asking myself the same question. But I'm not convinced yet. Right? I'm not convinced yet because I'm not seeing earthquakes elsewhere. I'm not seeing clear signs of magma moving elsewhere. Like the clearest thing to me is looking at that INSAR image. Let me pull it back up here. Right, the magma is refilling the exact same place. It doesn't look like it's going anywhere else. So I think it's doing the same thing. The magnitude of the deflation cycles is still very small compared to the magnitude of the inflation. So it's showing signs that it's going to change at some point. And usually we can't tell in advance, and maybe we're trying to do that now, but I still am not convinced we're seeing anything that shows us imminent.
Right. We don't know what the sequence is that it ends on, but for me, my money, is still on it going out with a bang rather than a whimper, and that some kind of earthquake changes the system.
Yeah, I think that's likely as well, most likely as well. Let's see a big south flank earthquake opens a rift zone,
and then it changes
the amount of magma reservoir underground and its shape,
and the pathways, the resistance,
and the pathways.
Yeah, that
might slow it enough to start hardening or closing off bits of the conduit. Now you can reset. So like it might take something like that, right? Or another thing is that the magma supply rate, as far as we can't measure it like instant to instant, but it seems like there's a lot of lava coming out faster and faster, right? So at some point, do you run out of overpressure, let's say, and you kind of slow it down? Maybe that's one possibility, right? Does that magma supply suddenly shut off? It doesn't seem likely after year. How long has this been going? Since more than 10 years?
It also could be that it's whatever Ken was talking about, it drawing from the south chamber extra to make up for the supply rate, and that it can stop drawing from that supply, that extra.
Right. That's what I mean by overpressure, right? Like it's got like extra pressure in there that it's just venting that off in addition to whatever it's feeding it into, right? So, if you run out of that, and you turn on your supply, now you can slow the magma down. That's another way, but that's two things you got to do there, and I'm not sure we've done that yet.
Right. We got another question here. Orchid Owl asks, so is there signs that the next Mauna Loa eruption could be from the southwest? I assume rift zone, not chamber.
No, there's no sign of that yet, right? And there's going to be no way to know that until it erupts, most likely. Right? Because the thing is, let me pull up the Mauna Loa.
We know where Mauna Loa starts. It starts at the summit, but from there, it has three options. Stay at the summit, go north, or go south. Once it goes north or goes south, it doesn't change. It sticks with it. But at that time, when it pokes its head out of the summit, it's kind of we still don't know.
Let me show you guys. This is just a paper that came out after deep earthquakes under Mauna Loa occurred back in 2004 to 2005, more or less. And so they're right under the summit region here. Part of that pathway. It's a little extra here, but what I want to show you guys is this. just because it's the easiest place I have to find it, right? So here's where those earthquakes located, deep, deep, deep down. And so straight up pathway directly above it. This is the model that's often used. Is this circle is that little magma chamber that's small and near the surface by the caldera. But the main volume of magma stored in Mauna Loa sits along this line, which is a big dike. It's a tall blade. It's not very thick, but it's very long. And it does extend under the southwest, right? So this is why you see seismicity southwest. This is the feeder zone. The feeder zone is not like one big spherical area. It's this funny blade shape plus a little bulb attached to it. That's what makes it weird. So all this area fills and quakes normally, that's normal. And then only after it erupts at the summit and then goes past here or past here, do you know that's left the summit and is going somewhere down a rift. So it's really hard to tell that in advance. And half eruptions don't even leave the summit. They just start at the summit, stay at the summit, end at the summit, and that's all there is. So that is still the most likely thing that happens every single time. And then beyond that, you have progressions that are required to be seen for you to say it's going to go into either rift zone or to prove that it's going to every rift zone. And quite often what we see happen is, fissures start at the summit and earthquakes start here, and they often migrate to the southwest, like in 2022, and then it'll come back northeast and open to the northeast. Right. So this is a very, very tricky zone that's very dangerous to base any prediction on because of this very complex nature of it right here. So that is the answer, best as I can describe it to that.
All right. So let's do maybe one more quick one. Let me make sure I don't got anything new. One more quick one. Down for that? Two Feathers asks, Kilauea is growing a lot like Mauna Loa did, isn't it? Mauna Loa also had a slump, collapses, etc. I think this is in terms of long-term progression.
Yeah, I mean, certainly it is growing a lot. Yeah, it's going to take it many, many years to reach that size, obviously, right? To be able to have as much volume and the slumps, the size that Mauna Loa has, especially it's on this west side over there. But yeah, it's the analogy I've often used, even back when I was giving tours, is that Mauna Loa is a full-grown adult volcano, and Kilauea is a teenage volcano. It's very energetic, going through a big growth spurt, but still does not have the power of the adult. Right? Mauna Loa is just much bigger, well-established, does what it wants, when it wants, and Kilauea has to stop what it's doing. But in the meantime, while Mauna Loa is happy to stand aside, Kilauea can be all energetic and do all this work and go through these growth spurts. And that's, maybe not the most scientific answer there, but that's the one that helps people understand, I think, the different stages of the volcanoes. And so yeah, it's growing very fast, very active, but it's not anywhere near the size and age of Mauna Loa yet, right? So.
All right.
Let's see another question earlier from, let's see here, Joan Morris on Facebook, when I was talking about the SO2 cloud going over to the northwest. The question was, are they going to get Pele's hair in the northwest? Here's the image I think we're talking about. And I've never heard of that. I suppose it's possible that some little pieces get caught way up in the sky. I remember in my early geology classes, people talking about how the dust from the Gobi Desert in China is so fine it blows all over the world, and it's in every sample everyone collects of soil almost everywhere. And so maybe there are some little bits of it that are caught and stay aloft. But I think what we saw in episode 41 is that most of it's going to fall out fairly close by. So most of it will probably fall in the ocean. And if anyone in the northwest does see any Pele's hair or knows any different, then please let us know. That'd be really fascinating to know. But
right.
I think they're probably a little too big to stay aloft that long, honestly, even when they are very thin and small and can go in our hands really easily.
All right. Well, I think that's it for me, and that's on the question front as well.
All right. Sounds good. Well, let's wrap it up then, right?
Yeah.
We'll see what happens in the next week. Next week will be just before the opening of the window. And so we'll likely be talking about that. We build up to 42. In the meantime, unless anything changes, that's when we'll be back with you guys, right? If something changes massively, like we're saying we don't think it's going to happen, then we'll jump in sooner. But otherwise, we'll be back with you guys next week on Thursday at our regular time, 5 p.m. Hawaiian time. Looking at the episode to come.
Yep.
Anything else, Dane?
Think that's it. We have some events coming up, but we'll be talking about them more next week as well.
I think we're going to be, before next week, we'll be at Hilo Union Elementary School, won't we? For another science night next Wednesday night. If you happen to be local in the area, Hilo Union student or other nearby, come check us out.
Yep.
All right. So until next week, from our nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute, our mission is to improve preparedness here by educating about volcanoes and all the associated processes. For our interpreters, Dano and Carrie, mahalo as always. For Luatori backstage and earlier in our community corner and observations, and for Dean DuPont, I'm Philip Ong. Until next week, aloha everyone.